Hello everyone, and welcome back to the channel that's saucier than the McRib and fresher than your mom's garden-grown kale. That's right, we're back with another Bowmaths video, and today we're going to be practicing what we talked about in the last video, which was proportion, specifically how we can use fraction multiplication to apply proportions to groups of any size that we want. So I've got a few interesting problems here for you today. So as always, pause the video, try them out yourself, and we'll get crack-a-lackin' together. Robert conducts many different orchestras. Suppose that in his orchestras, he always needs a proportion of 3/10 of the instruments being aerophones. So an aerophone, just to recall, is any instrument that produces sound by vibrating some sort of columns of air. So that could be a trumpet or a didgeridoo, an ocarina, anything like that. And if you're wondering why I'm specifically talking about this, then you must have missed the awesome video of Filipinos and Philharmonic proportions, where we talked about a lot of different kind of interesting things relating to orchestras and music and instrument classification systems. It was quite the interesting video where we didn't just do math, but you learned some stuff that you probably won't see anywhere else, at least not inside of a math video. And Robert, it was a new face that we introduced in that video, so it's definitely worth giving that a watch if you haven't yet. But in any case, we have this kind of rule for his orchestra. So regardless of what the orchestra is, there always needs to be this proportion of 3/10 of those instruments need to be aerophones. It says in an orchestra of 20 instruments, how many would have to be aerophones? We have a rule for basically what piece of our orchestra needs to be aerophones. And so basically we just need to apply that piece to this specific orchestra with 20 instruments. So the way we did that was with fraction multiplication. So if we take the proportion of 3/10 and we multiply it by the size of the orchestra, which is 20, all right, so doing that, we're going to get 3 times 20, right? This is the same as 20 over 1. We can just multiply the numerator with the 20. We get 60 over 10, which is 6. So that means 6 of the instruments need to be aerophones. So maybe, I don't know, 2 are trumpets, 2 are clarinets, and 2 are flutes or something like that, right? So 6 of the instruments in his orchestra need to be aerophones, and we found that by applying the proportion to the group size. For part B, it's very similar, except we've just upped the size to 100 instruments now, right? And a lot of big orchestras actually do get to, in around 100 instruments. But if we apply this proportion, we're just doing 3 times 100, which is 300 over 10, right? Just our standard fraction multiplication. We've been doing this a lot. 300 divided by 10 is 30. So that means 30 instruments need to be aerophones. All right, so this isn't too hard. What about C? Well, same kind of thing, right? We have 3/10 and we multiply it by 5. 3 times 5 is 15. 15 over 10, that's not going to be a whole number, is it? If we convert this into a decimal, this is going to be 1.5, right? And you can't exactly have half of an instrument. So even though Robert has this rule, he can't actually 100% stick to it because, well, you can't have a decimal amount of an instrument, right? You can only have whole number amounts of instruments. So what he has to do is he has to choose, basically, does he want to round this up to 2 instruments? Or does he maybe want to be a little more conservative and round this down to 1 instrument? In both cases, neither will be exactly that 3/10 proportion, but it's going to be close to the 3/10 proportion, right? For example, if we did 2 instruments, okay, we're looking at 2 instruments out of the total of 5 instruments. 2 out of 5 is 0.4. Or we could do 1 instrument out of the total of the 5 instruments. 1 out of 5 is 0.2. So neither are the 3/10 or the 0.3 that is the proportion we want, but we're going to basically have to round this and get something that's relatively close to that proportion of 3/10 or 0.3. All right, so that's maybe a little bit more of a realistic application of proportions where you don't always get a perfect representation of your proportion because you can't have things like fractional amounts of instruments or fractional amounts of people or anything like that, right? So oftentimes you're going to have to do some rounding and make some choices. And for extra practice, kind of like I did here, just make up different scenarios with different proportions and apply those proportions to groups of varying sizes. You have opportunity to have some fun here where whatever you're interested in, make up a scenario for it, right? So get a proportion for that, and then apply that to groups of different sizes, right? And that's just going to correspond to your fraction multiplication. Let's move on to question 2. All right, so question 2 says, suppose 3/5 of mathematicians are male and 1/3 of males suffer from male pattern baldness. So these aren't actually true numbers, but I just chose these numbers because, well, they work out nicely. So for the first question, it says, out of 1,000 mathematicians, how many should be male? So we're looking at 1,000 mathematicians, and we're going to want to apply some proportion to it. Well, we have two different ones to choose from. We have 3/5 and we have 1/3. But the 3/5 refers to how many mathematicians are male, right? That's the piece of mathematicians that are male. So that's going to be the proportion we apply to the 1,000 here, because we're looking for how many should be male. So if I do 3/5 times 1,000, what I'm going to get is I'm going to get 3,000 over 5, which is going to be 600. So 600 mathematicians will be male. All right, part B, it says, out of 600 men, how many should have male pattern baldness? All right, so we're taking 600, and we're going to want to apply the proportion that relates to males suffering from male pattern baldness, and that's going to be 1/3, right? It says right here that the piece of males that suffer from male pattern baldness is 1/3. So when we apply that piece to this group of 600 men, then what we're going to get is just this product here, right? 1/3 times 600, which is going to be 600 over 3, which is going to be 200 men will have male pattern baldness, which I'm going to abbreviate as MPB. All right, so far this is pretty similar to what we were doing in question 1. But now in part C, this is actually going to be something a little closer to what we were looking at back in the symphonies video. So if you haven't seen that yet, that's going to be useful for this question. So it says, what proportion of mathematicians would we expect to have male pattern baldness? So to get this, we can't just apply 1/3, because in order for those mathematicians to have male pattern baldness, they also need to be male, right? A female can't have male pattern baldness. Yes, there are examples in females where they have some form of baldness, but that's not specifically male pattern baldness. So what we need is basically to figure out first the piece of mathematicians. What piece of these mathematicians are going to be men, because that's a prerequisite for having male pattern baldness, and then what piece of these men are going to actually have male pattern baldness. To get this first piece here, we need to basically use the proportion of mathematicians that are male, which is 3/5. And to get this second piece here, we need to use the proportion of males that have male pattern baldness, which is 1/3. And since we're doing a piece of a piece, notice I'm using that word of, which we talked about is multiplication for fractions. What we do is we actually multiply these fractions together. We do 3/5 times 1/3. So 3/5 times 1/3, that is us applying these fractions to each other. Even in part A and B, we always multiplied when it came to applying fractions. So this is no different. We're just applying these two different fractions to each other by multiplying them. And so what we get is 3 times 1 in the numerator, which is 3, and 5 times 3 in the denominator, which is 15. And this can be simplified down into 1/5. So the proportion of mathematicians that have male pattern baldness is 1/5, right? We're doing a piece of that piece, or multiplying them together. So this is the piece of mathematicians that are going to have male pattern baldness. Okay, so now what we can do is if we look at part D, it says use the proportion you calculated in part C to find out how many mathematicians out of 1,000 should have male pattern baldness. So it says use this proportion here, 1/5, to figure out how many mathematicians out of 1,000 will have male pattern baldness, right? Because this proportion is telling us the piece of mathematicians with male pattern baldness. So if we apply that to a group of mathematicians, we're going to know how many in that group have male pattern baldness. So if I do 1/5 times 1,000, that's the same as 1,000 over 5, which is going to be 200 mathematicians will have male pattern baldness. Now I want you to notice something. We get 200 here and we get 200 here. And also, we started with 1,000 in part D and we had 1,000 in part A. And then also, we ended with 600 in part A and we got to 600 in part B. Now, is that just a coincidence with all these numbers? No, I actually chose these numbers very particularly because notice what we can do. If I start with 1,000, which is the 1,000 mathematicians, right? So if I start with my 1,000 mathematicians, and then I do what I did in part A, and I apply this proportion of 3/5, I know that that gives me 600, right? So that's basically saying 600 of those 1,000 mathematicians are male. All right, that was just part A. And then in part B, I applied this proportion of 1/3 to a group of males, right? The 600, which is a group of males. And we got 200, right? So out of the 600 men, 200 had male pattern baldness. But I want you to notice something. If I take that 1,000 here, and I multiply it by 3/5 and by 1/3, that's doing the exact same thing as what we did over here, right? First we took the 1,000, multiplied it by 3/5, that gave us 600, and then multiplied it by the 1/3, that gave us 200. We essentially did 2 steps to go from 1,000 mathematicians to the piece of them that were men to the piece of them that had male pattern baldness. And over here, if instead of doing this product first, what if I actually do 3/5 times 1/3 first? Well, we did that in part C, right? That was 1/5. So now if I say, okay, this is the same thing as 1,000 times 1/5, which is what we calculated in part C, we know that this was the proportion of mathematicians, right? 1,000 mathematicians that had male pattern baldness, and we also got 200. So we get the exact same thing, and both are telling us the same thing. Out of these 1,000 mathematicians, 200 have male pattern baldness. It's just here we combined the proportions first and then applied that combined proportion to the 1,000 to directly go to our answer. Whereas over here, we applied each of those proportions separately in 2 different processes, kind of getting our piece and then our piece of that piece. But both times we get the same result. And so that's an important kind of aspect to notice, is that because it doesn't matter the order in which we multiply things, we can either go by this route or we can go by that route. And they both kind of give us a slightly different perspective on what's going on. This kind of breaks down the process a little bit more, and this just takes us right to our answer. So I hope you found part 2 interesting. I think it's a really nice kind of visualization of, how you can do things in different orders with multiplication and, combining topics we've learned with proportions. So let's go on to part 3. All right, so part 3 says, suppose that the proportion of people who like math is 1. What does this mean? So you might be a little bit confused because all the proportions that we were dealing with were fractions, right? And 1 isn't a fraction. But let's maybe try and apply this proportion to different groups and interpret that, and then maybe we can get an idea for what this means in general. So if I take my proportion of 1 and I apply it to a group of 50 people, well, I get 50. And since I applied my proportion to that group of people, the proportion was telling me what piece of that group of people like math. This is basically me saying that 50 of those people like math. Okay, let's try another one. What if I do my proportion of 1 applied to a group of 100 people? Well, then that means that out of those 100 people, 100 people like math. What do you notice in both of these situations? The entire group likes math, right? So this proportion of 1, since 1 is like a whole number, right? It's not a piece of something, right? 3/4 is a piece of a whole, but 1 is the entirety of it, right? 1 is the entire whole. So if you're applying that proportion, then basically you get back the exact group size. The entire group satisfies this property. So this is essentially saying everyone likes math, which, what a utopia we'd be living in if that were true. But yeah, everyone likes math is what this proportion is saying. And we can break that down. Remember that 1 is the same thing as 1/1? Oh, now we see a fraction, right? And remember, what did fractions tell us in terms of proportions? The numerator was how many kind of satisfied that property, and the denominator was the total. But here, our numerator and denominator are the same. That means the amount of people who like math in this case, or satisfy the property of the proportion, they are the same amount as the amount of people you're looking at. So that means every single person likes math in this situation. Every single person satisfies the property of whatever the proportion is measuring. So that's kind of just an interesting example, and it's going to become relevant in the next lecture video when we talk about percentages. But let's move on to the last question for today. All right, so this says, suppose 3 out of 4 dentists recommend a toothbrush. So I know it's not the classic 9 and 10, but I had to change it up a little bit. So suppose 3 out of 4 dentists recommend a toothbrush. Part A says, in a group of 100 dentists, how many would we expect to recommend this toothbrush? So once again, we're just applying the proportion to the group size. All right, so we do 3/4 times 100. So 3 times 100 is 300. and then we have 300 divided by 4, which should be 75. So that means 75 out of those 100 dentists would recommend the toothbrush. All right, so that's nothing new, right? We just did that with the previous few questions. But part B is where it gets a little more interesting. It says, discuss how the double action of multiplying by 3/4 helps us find what piece of the 100 dentists represents this proportion. So we just did this in part A, where we basically multiplied by 3/4 and we found the amount or the piece of the 100 dentists that represented the proportion of 3/4, right? And we know it represents that because if we do 75 out of 100, that simplifies back down to the proportion, that 3/4, right? So we basically found the number to put in the numerator out of this total of a 100 that gives us the same proportion. But this is saying, how can we interpret this through the perspective of double actions, right? Multiplication by fractions, we saw could be interpreted as a double action of basically multiplying by the numerator and dividing by the denominator. So how can we think about that here? Well, if we take 100 and we multiply it by 3/4, the double action says that, okay, we can start with the 4 in the denominator. So if we consider the division by 4, that's the denominator action, then 100 divided by 4 gives us 25, right? And then we still have to multiply the 3, which is the numerator action, which is going to be 75, right? So that gives us the same thing, but what do these actions mean? Well, what we did is we took the 100 and we split it into 4 groups. All right, so this is necessary since our proportion involves a total of 4. So we need to start by splitting this into 4 groups, and each of those groups are size 25. Since our proportion is a total of 4 of these groups, and in our case it's 4 groups of 25, then to get the numerator, we need to basically count how many groups we have, and that's going to be the multiplication part, right? We need 3 groups of size 25, right? So we took 100, split into 4 groups, and now we're taking back 3 of those groups. So that's where the multiplication by 3 comes in. So that gives us our 75 dentists, right? That's how we're able to get this 75 that gives us this fraction that is equivalent to our original proportion. Okay, so I hope you found that video useful. I hope you're starting to feel comfortable with all these different perspectives on fractions and proportions and fraction multiplication. And we're going to continue going with this with a really important lesson next time, which is percentages, used all the time in the real world, so you're not going to want to miss that. But until then, you have a good one, you stay groovy, and I'll see you in the next video.
F.O.A. Maths.